Good afternoon, students. This is Mr. Cohagen here, and we are going to be discussing Greek astronomers today. The purpose is to give you a background regarding the many, many contributors to Greek astronomy and their ideas and beliefs that help kind of shape what we know and believe about the heavens today. Your objective is to understand those beliefs and how they specifically shaped those individuals. It's important for you to focus on the individual astronomers and their ideas. So please be prepared and ready with your Cornell notes at this time so we can get started. I want you to make sure that you take good, thorough notes, and if you need to rewatch this, please do. When you bring your notes in tomorrow to class, you will be working together on a specific assignment, which I'll detail at the end here. It's important to know that the Greeks didn't just come up with astronomy. They had actually encountered other civilizations, such as the Mesopotamians and the Zoroastrians, and built upon what they also knew. So we have a lot of contributors to what's going on with the Greeks here. The Mesopotamians and the Zoroastrians inhabited this area known as the Fertile Crescent, which you can see here highlighted on the map, is a very rich areas where people lived and agricultural was the main means of life. They needed to understand the heavens and what was above because they understood on some level that it had something to do with when the river valleys flooded. And if they could take advantage of when the river valleys flooded, they would be able to plant and grow crops and be able to utilize those all year round, or at least not miss out and starve. Okay? The Greeks kept some of the ideology of those groups, such as that there were gods and there were omens related to what was going on in the skies. But they also understood that this was a specific theology and that they wanted to go beyond that. They weren't satisfied with just that phenomenon. They wanted to know how and why things worked, which is a huge tenet of the Greek culture. How and why. Okay, and Abbott students will also understand that because we talk about that concept all the time. One of the earliest Greek astronomers and philosophers that we know about was Thales of Miletus. As you can see here, he was a huge contributor early on. He was the first to predict an eclipse. He was the father of trigonometry, and he gave us the basic diameter of the sun very, very early on. We're talking about things that were 2,000, 2,500 years ago, okay? He also recognized the importance of the stars in the skies to those who were on the open water because they needed to use those to navigate. Please also note that with Thales, he is going to help emphasize for us the link between astronomy and mathematics. Without mathematics, we don't delve into astronomy. These were all philosophers, mathematicians, and that was part of their belief system, and that's what helped drive them. And Anaximander of Miletus, as you can see, gave us our first model. He said that the Earth was basically hanging in space with other heavenly bodies kind of circling around us, which to a certain degree is correct. However, we know now that we're not at the center. And in his model, he believed that it was more of a cylinder shape and not a sphere, much like a toilet paper roll. He did give us the concept that the universe was unbounded, that it was infinite, that it didn't just stop and we would slide off of the edge. Pythagoras, one of the most famous Greeks that we know about in our time, did give us the concept that Earth was spherical. Excuse me. He noted that when ships would sail out to sea, that they would rise and then disappear down again over the horizon. And that to him signified that all of the Earth was curved, not just a specific part of it. And that if the other bodies that we could observe in the sky were round, then we should be as well. He also noted that Venus, which is the morning and evening star, was the same thing. It wasn't two different stars, and that it was indeed the planet Venus. Anaxagoras noted that the sun actually had a huge mass, that it wasn't the tiny dot that we see in the sky, but assumed that it was blazing metal, which is correct to only a certain degree. He thought the heavenly bodies were actually pieces of earth that had just been broken off instead of what we now know as pieces of rock that have come together. Okay. He also hypothesized correctly that the moon was much like planet Earth in that it had valleys and mountains and ravines. And although it wasn't inhabitable, he thought it was, but we now know that it wasn't. He also, for whatever inexplicable reason, went back to the idea and concept that Earth was flat, which we also know is not true. And he did give us that the moon reflected the sun's light, which it still does today, obviously. Heraclides did one major thing for us. He was the first to tell us that the sun was at the center of our universe. And the problem with that is that he didn't, his ideas, I should say, weren't really adopted for another 2,000 years when Copernicus popularized that theory and proved it. Here we have some group work being done. Aristarchus and Eratosthenes, they gave us this idea that you can see here, celestial distance, that the universe was far much more grand in size than just what we could observe in front of us in little pinpoints in the sky. All right. Almost correctly, they proposed that the stars and the sun didn't move in the sky. We know there is some limited movement. It's not real great. Instead believing that the Earth is rotating about its axis. So as you can see, as we start moving forward in this process with the Greeks, things are getting more clear. Things are becoming more closer to what we know, we understand. Hipparchus, Ptolemy, and the epicycles. Here we have two greats. Hipparchus believed that the Earth did not lie at the very center, but slightly off. We know that we're not at the center of any universe, but we know that we're at the center of our solar system. So he's very, very close. Again, let's note the use of mathematics. Using trigonometry, Hipparchus and Ptolemy came up with these epicycles where the sun and the moon moved around Earth. So we're still not quite at the sun as the center, but we do note that there's this cycle of activity going on. And this is going to be important because there was a very, very unclear delineation between why things moved in the sky, why we couldn't always just look up and pinpoint what was going on. Ptolemy's work, which was called the Almagest, was working with Hipparchus, and it was that sailors and maritimers used in the centuries preceding this to still navigate the seas. Obviously, we didn't come to any technological advance electronically up until the 20th century. So these were still ideas and concepts that were very important for many, many centuries because they helped guide trade and travel throughout the world. Should you have any questions, I want you to make sure that you refer back to these lists of resources, which is what I used to derive this lecture. These resources are also going to be listed on the webpage for you to peruse. And I want to remind you that of two more things, that there's a quiz related to this lecture on the webpage as well that you can take at any time. Obviously, it's 8 questions, so the goal is to get 8 correct. You can watch this video as many times as you like. When you come into class tomorrow, I'd like you to be prepared with your notes so that we can discuss these astronomers further. And I'd also like you to pick one astronomer that you can delve a little bit more deeply into so that you can be prepared to discuss their contributions and their ideas and beliefs. If you have any questions, please feel free to contact me. Other than that, please have a good afternoon. I look forward to seeing you tomorrow.